Today we're going to present to you kind of a real-life workflow that uses a major CAD and PLM platform, the Siemens NX and Teamcenter platform. And it's a use case of how, we'll illustrate how using QIF, UUIDs, we can run model-based characterization workflows in a real environment. So we can start with some intros. So my name is Daniel Campbell. I'm the Vice President of Model-Based Definition at Capvidia. And George.
Afternoon. My name is George Rendell, part of Siemens DISW. I'm the Vice President of Product Management and Product Marketing for the NX Design products and also for the Siemens Open Tools products. Pleased to join Daniel today in this session. And first time here at the summit and conference. Pleased to see so many existing of NX customers and software partners here. So thank you.
So we'll start off, we'll do a little bit of background just quickly about our companies. So I'm with Capvidia. I'm the Vice President of Model-Based Definition. And so Capvidia, we focus on MBD-based solutions to enable a lot of these pillars of Industry 4.0 that we see here. We really focus on semantic model-based definition, machine-readable model-based definition, and understanding how that could be exploited throughout your entire enterprise. We're mostly working with the large OEMs on this on these technology launches. A handful of customers are shown there to kind of give a representative idea of the types of industries we're working with, which is really all over the place. George?
So on the Siemens side, the graphic here is intended to represent the areas of engineering, manufacturing, and quality that we serve. In the upper left, in the mechanical area on authoring, that's an area that I'm responsible for, perhaps a little new to the conference. And down here in the operations and manufacturing areas, we offer some products called Teamcenter Quality, OpCenter, and EasyPlan that address more of what traditionally this group has talked about.
So let me give a little bit of background. Again, there's been already a lot of talk, as you've already heard, about this idea of model-based characterization, characterization of a model. So I think everyone's starting to get the general idea of what this emerging sort of concept is. But so let me, sort of paint a little further color here. So to think at the legacy state, so let's say our current state of how we view product data in terms of the entire enterprise. Right now, the more or less the atomic unit of data is a part. In PLM we have our part, and that's pretty much the lowest level of resolution that we see throughout our enterprise. But there is starting to emerge this vision that that's not good enough, because what do we have in our model? We have our characteristics, our bill of characteristics. And these are very important aspects of our model. Right now, the traditional view is that that's quality's business. It's quality's business to take the drawing and then balloon it and create a first article inspection. And me as a designer, that's not for me. That's not for me. But actually, that really doesn't make any sense, because who's the person who's putting on those requirements in the first place? It's the design engineer. And so whether that design engineer realizes it or not, they are creating a bill of characteristics. It might just be an implicit sort of vague idea that actually gets instantiated at quality, but it shouldn't be like that. It's at design time that bill of characteristics should be generated, and the designer should sort of consciously be thinking about what are the characteristics on this model that we need to manage. And so that is the vision that's emerging. That's what we're talking about when we talk about model-based characterization. And so thinking about the new state, yes, this is starting to think of these model characteristics as valuable business objects that are tracked across your enterprise. So these should be formally instantiated within a CAD system. They should be tracked within a PLM system. And you should be able to sort of trace workflows. In this case, this is where QIF fits beautifully into this. Trace workflows throughout your entire enterprise, including your supply chain, that track back to these characteristics. George, would you like to talk a little bit about this vision?
Sure. So on the NX product side, I'm going to have one short slide on the product, and then I'll go into 3 detailed slides on what we're doing with NX and characteristics. So Daniel's given me the should. So I've got to turn the should into we are doing and we will release and deliver. So I'll discuss that in a couple, 3 slides. Daniel will then go into some AVIs that show how the whole process works, and then I'll come back in a slide that talk about the digital thread and the whole process. So the short on the NX product, that's the product name that I represent. Again, I'm kind of up in here in this 11 o'clock on the wheel in model-based definition. Model-based definition in NX are all our capabilities for product and manufacturing information, or PMI. We've been supporting PMI since the beginning. We were the only software vendor that had members on the committee, originally with ASME, starting in 1997 through the release and the publication in 2003. We were the vice chair on the ISO committee that published in 2006. So we've been doing PMI for over 20 years. We've been doing CAD geometry for over 50 years. Today starts, or this year starts, our endeavor into characteristics for NX. And we'll talk about that and announce some new things in the session this afternoon. Daniel?
So next, a little bit about some of these design and characteristics, the data model.
Sure.
Yeah.
So all of you are going to know this slide, even though it's my slide, better than I do based on what I've learned from being here this morning. So if there's any hard questions, feel free to ask yourselves. But to make it real, again, on the NX part data file, obviously we have a lot of geometry types, we have a lot of PMI types, we have a lot of attribute types. What we are adding into NX, as represented by this slide, are characteristics. We're going to associate the characteristics with the PMI that I mentioned on the previous slide. PMI is already associated to the geometry. We're going to add characteristics in a DMSC compliant manner so that we will align with the work that you as groups and committees have been doing, and therefore enable the input and output of QIF through Capvidia and through our NX Open tools. Second slide gives you a little bit more graphics. As a designer or MCAD guy, I'm really familiar over here with the geometry. Obviously, we have the PMI types. With the characteristics, we'll have the ballooning and tracking that you see. Those things will be associated into a bill of characteristics. Those bill of characteristics will be associated to the PMI, PMI back to the geometry. Earlier in the first session, I think, Daniel, that you kicked off today, you talked about the word features. Features gets us a little confused because traditionally in MCAD, our definition of features are different than manufacturing or quality definition of features. So I'm going to try to avoid using the word features, but the key thing from my perspective is the associativity and the links. These things do not have to be one-to-one, they could be one-to-many. Both from the geometry to the PMI back to the geometry, the PMI to the characteristics that will be new in NX, and the characteristics back to the PMI. If you look at a preview of what we will release, the enhancement for characteristics in NX design will be delivered to the market before the end of this calendar year. This is the first public announcement that we are underway with these enhancements. What you see here is an early screenshot of what we're doing in the characteristics field. So of course you see the NX screen, the geometry, the PMI, the ballooning and notes. And what we're looking to do in the NX system is add what we would call a characteristics navigator. So for those of you who are NX customers, we have part navigators, we have assembly navigators. We will now add a characteristics navigator. Characteristics navigator in our terms are the ability for the user to interact with the characteristics in the NX system. Also, not to get too far ahead, but to preview the process stuff at the end, also very sensitive to where the expertise is within your companies as to doing characteristics. The expertise may or may not be in the CAD user or in the mechanical engineer. They could be in the quality department or in other places. By having the characteristics data in the NX part file, we can make that read only or read and write. So in smaller companies, you might have an NX user doing some of the characteristics. In larger companies or larger environments, you might have a Teamcenter quality user or a user of other tools, partner products, doing those quality characteristics. Those things through QIF can come back into the NX part file. Any criticality can be tagged as attributes. So to me, it's important that even though management likes to say shift left doesn't mean put all the work on the first person that starts, in my opinion. It means that you have to have an engineering change process or traceability that allows the right person in your organization to do the right work. Limitation today in MCAD within either NX design, and again, especially with our competitors' NX products, there's no ability to see or understand those characteristics. So what we'll have with the bidirectional QIF translator from Capvidia, and also within the Team Center suite, is an ability to cross-probe back into the NX session, so that if the quality plan and the characteristics come from one of our other user applications in our suite, they will be visible and exposed to the NX user. So on an engineering change cycle, they can know what those are, they can see them, but they would be protected from not editing things that they're not responsible for. So a little more verbal, but that's trying to be what this simple screenshot is showing. Daniel? I think this is a little bit of you and a little bit of me before we get into your workflow. Maybe to make all this real on the NX side, I'm now going to move past the high point and 12 into the 1. So if I look at the puzzle piece on the diagram here that you all use to represent QIF, in the upper 1 you list CAD and PMI, but don't list characteristics. And to me, one of the challenges that I see from listening and working with customers is the linking and the traceability of the characteristics. So in NX, by adding the characteristics up in the MBD land with the geometry and with the PMI, all those three things will be together in a single source of truth. I'm done. Thank you very much for your time. I'm not answering any questions. I think that's a good thing. So if we're handling that in step 1, then with the QIF bidirectional translation, we can help you walk around the wheel for the things that you need in your digital thread. And as mentioned, NX has the geometry and PMI today, and what we will do is add the characteristics as just described. To me, what is also important is that anything added to the NX part file is supported in our NX Open API. Our NX Open API gives partners and customers and competitors an ability to create or extract information from the NX part file into other systems. Because you have the UUIDs in the QIF format, that would allow other vendors or yourselves to do some traceability and tracking outside of the Siemens product set. So the QIF data format or file format or XML format, I'm not sure if I got the terms right yet, has the 3 factors. All 3 of those factors will be in NX with the updated release, where today 2 of the 3 are there. So today with the Capvidia QIF translator bidirectional, you get the geometry and the PMI, but we don't have characteristics. By adding the characteristics into NX and into the NX Open API, Capvidia, as well as potentially other partners, can read and write all 3 pieces, and again, help you eat the pie as you need to satisfy your digital thread. Capvidia, I'll speak on your behalf before I turn it back over to you, has also agreed to support the enhancements for characteristics in sync with when NX does its release of the characteristics enhancement, obviously by leveraging the NX Open API.
Yeah, no, it's exciting stuff. So a little bit about what I'm going to do next is I want to show a very simple workflow that illustrates what we could do in terms of utilizing these characteristics through an entire sort of workflow realization of manufacturing parts and doing measurements. But first, I did want to say a couple words about UUIDs. What are UUIDs? So the question is, what is the problem that UUIDs solve? I think when thinking about UUIDs, we should be careful about not running into what sometimes people call a solution in search of a problem. The question is really, what data do we want to track? So in an entire enterprise, there are many different silos that are all separated out. And there are some pieces of data that need to be traceable throughout more than one silo. I mean, an example that we have would be a part number, like I mentioned earlier. You know, a part number might, it's sort of its home, might be a PLM system, but you can reference a part number throughout many different domains, and that means something. That's a form of an ID within your organization. It's an ID, it's a unique ID, and it's universal within the context in which it matters, which is your organization. So it's a form of ID. So that's an example of a piece of data that you do want to track throughout your enterprise. So what else needs to be tracked? And whatever we need to track, maybe a UUID is a good answer of how to track it. So really the fundamental question is, what do we want to track? That's really what we want to answer. What's the data that we want to track? And in this case, I think the key answer is, it's model-based characteristics. I mean, that's really what we need to be thinking about when we talk about the idea of UUIDs and traceability and so forth, is these critical enterprise business objects that need to be followed throughout workflows across domains. So I'm going to give a sort of a low-level example, a very simple example of just to kind of illustrate with existing software tools how you can track a UUID throughout a product lifecycle. So what we'll see is we will start by characterizing PMI inside of NX. So that means that it's not, you know, as George is explaining, it's not just the model and the PMI, but now there is this sort of extra layer of intelligence, which is the characteristic. So we'll start with that. We'll take that out to QIF, and we'll generate a derivative QIF model that will reflect those exact same characteristics that exist in the design model. We'll flow into DMIS, CMM software, and we'll see how all of those same IDs exist now in a metrology software package. We'll run some simulated measurements, output some QIF results, and we'll show how we'll bring those results back to the QIF, back to that bill of characteristics, which establishes that chain of traceability back to the native model. So we'll start out. So here's an example. I mean, so what we're looking at here, this is very basic. I mean, we're looking at the characterized NX model. I mean, so here it's a very simple little widget model. What we see are the human readable balloons. You know, let's say underneath the hood, we also have the UUIDs, which we can't see because they're not really meant for the human. And you might wish you could see them for this demonstration, but I can assure you that if UUIDs were visible on the screen on an ongoing basis, it would be very annoying. And so yeah, I mean, this is our starting point. This is our product definition. And so this should be sort of the route by which all of your product workflows, you know, should be traceable back to. So next step, we will generate that QIF, and we'll view that bill of characteristics. We'll start working on that bill of characteristics inside of in QIF in MBDVidia. So here we're looking at the model in Capvidia's MBDVidia software. This is a derivative model of that NX model, so it should match the geometry, it should match the PMI, but now with this new layer of information, we should also match on the characteristics. And that's what we see. You can see it kind of called out. Balloon number 1, 2, 2, 3, 3. So we want to make sure that this bill of characteristics matches in our downstream data, our downstream QIF data, that it matches what we would see in the native NX product definition. So now we've established that bill of characteristics in QIF, and we're ready to run through some quality workflows. So let's take that QIF, and we'll load it into DMIS, and we'll carry out some CMM inspections using a popular CMM software. So we'll load it up, we'll start generating the, you know, all the settings necessary in order to start with this measurement, bring in the part. We'll pop up the human readable balloon numbers here in a second, and so we could see again the you know, sort of the trail of these characteristics. Here we see it, 7, 8, 9, 10, 11. Again, these are the human readable balloons. The UUIDs are there, and that's what's used to establish the software traceability. But so we could see those breadcrumbs that are still sort of sprinkled throughout the entire workflow to leave us with that sense of traceability. So here we are, it's going through, it was able to read the PMI automatically, so you don't have some poor guy typing in PMI. It's setting up the program, generating an optimal CMM path to run around and gather the inspection around the entire part. We'll see a simulated inspection here in a second. And what it'll be doing is it'll eventually start outputting the inspection results in the QIF format. So it'll be dumping QIF files that correspond to each of these simulated CMM inspections on this CAD model. So the output of this is that we will see a set of QIF results files. And what we're going to show next is how we could establish that traceability between those QIF results files and the bill of characteristics, and ultimately back to that native NX where the characteristics ultimately live and are truly defined. So there's our CMM inspection, and there's some of our QIF files being generated. So the final step in this video. So again, here in this case, we're back in MBDVidia with the QIF file, which has the ability to import those QIF results files that just came out of that PCDMIS program. So we'll pull that data in. Because we had all of the traceability established with each of these characteristics on the model, we're able to keep the associativity in a very straightforward way. And actually what we're looking at here is a set of, I believe it was 10 sets of results. So the idea would have been 10 different components would have been inspected. So you're able to do all kinds of statistics, look at, in this case, just thermometers, but run charts and things. So here we have the characteristics again. So up here, this is a screenshot of NX with all the characteristics where they were originally authored. Here in the, on the QIF model, we'll see where they are on the QIF MBD. And then down here, we could see them in the bill of characteristics. And yeah, so as we trace through, characteristic 1, and then characteristic 1, and we're able to trace through not only the characteristic data, but now all this results data that's been captured from the PCDMIS inspection as well. So, really what we're looking at, it seems pretty simple when you look at it, because, this is, it really is trying to look at this in a simple way, which is a characteristic-based way of understanding some of these workflows, and simply establishing that chain from the NX through QIF into down, manufacturing parts, inspecting parts, and just maintain that data at every step. And that will help to establish this enterprise-wide traceability of the bill of characteristics data. So again, what we did, so we started with the model in QIF, or in NX, characterizing that model in NX, outputting to QIF, viewing the bill of characteristics there, carrying out inspections in PCDMIS, bringing back in results, and ultimately, this is the key, being able to establish that link all the way back from the quality domain back to your CAD PLM domain, and maintaining that chain of traceability. So this is a very specific example, I think, just to give people an idea of the types of specific workflows that can be implemented using this technology. George, maybe you'd like to talk a little bit about sort of the bigger vision that
yes,
you have.
And before we go to the next slide, obviously what Daniel here shown worked quite well within the Siemens products. In the Siemens products plus the partner products, what you have it with this line is some traceability all the way back, but you don't have a clean and robust engineering change process. And by adding the characteristics here, that takes the requirements out of your customer companies to do the middleware to try to track that. Question?
Yeah, mic around.
I should say easy question.
It might be an easy question.
Excellent.
Curtis made the point that the two big things in QIF are features and characteristics. It's not clear exactly how you're planning to use features here. what you could do, and maybe what you're planning to do, is have an other shape characteristic associated with a bunch of CAD faces. But in order to do that, presumably your PMI must be associated with a group of CAD faces in the first place. Do you have specific plans for carrying through and using QIF features?
So I think the first part of the question, I think, perhaps comes to me on the word features, which I specifically asked no one to ask me any questions about. So notwithstanding there, on the design side, the things that we historically think of features are not the same as the features defined here, or as what I would call manufacturing features. What I'd prefer to do is have a different word under as features to groups of geometry. First part of the answer to your question, though, is on the PMI in NX, yes. The PMI is associated with geometry, and that geometry can be associatively updated, and the PMI will track to geometry. And if the PMI is tracked to geometry faces that disappear, the PMI are left hanging in space, and what NX does is tell the user that you had a PMI to a piece of geometry that's no longer there. Do you want to go ahead and delete it? Do you want to reassociate it to a new face? So if the face doesn't change, if you will, then the PMI doesn't know what to attach to. So the first part of your question is yes, we already have the structure and the mechanism in NX for PMI to be associated to geometry faces or items as opposed to the design features. I think the second part of your question is a possible future enhancement. If we group features or geometry faces in manufacturing terms that might mean something different, that would add a layer of abstraction that may help this overall workflow. That is not in this year's plan for NX. However, what I would say is we have a lot of things in NX where we have an AI algorithm to help the user select things. So if you have a very complicated product on the screen, you could have tens of thousands of geometry faces. So if you pick something that NX thinks is a manufacturing boss or some other manufacturing feature, there's a way for NX to tell the user or highlight things and say, is this the collection of geometry you want? The user can accept it and go if the AI works. If our proposed selection doesn't match, then the user would have to go and select all those items. So I would say it's possible today, but it's not as clean as it could be if NX understood the manufacturing collections of geometry. And I think that answers your question from an NX perspective. From a more general QIF, do you want to add anything, Daniel? Or?
Yeah, in QIF, I guess we are formally creating the features. But I think that it's pretty easy to really rely on the associativity between the PMI and the surfaces in order to establish what that mapping is.
Yeah, we already have built in the other shape feature, which is nothing but a collection of faces.
Yeah, and that would be the fallback if it was some type of a free-form surface or something. But it's quite easy to say this surface or these couple surfaces. We look at them; they represent a cylinder shape, so it's a cylinder feature. And so that type of feature creation is pretty straightforward with the associativity of the PMI to the surfaces.
The other thing that you get in that regard in NX is if you have patches, depending on the types of products that you're making, and you have continuous or second derivative continuous, then when you select certain commands in NX, NX will try to find the whole sewn surface and do some other things to help in that regard. So the concept of collections of geometry that things are associated to are known in NX. What NX doesn't have is the manufacturing feature definition of all of those types today. Thanks for the question. If we go to the next slide, I'll tell you again about what the challenge is in today's releases and what the digital thread looks like with characteristics in NX. This is a little bit of a Siemens marketing slide on digital thread, so hopefully that doesn't throw you off. But on the design side, we're up here in the slide. Generally, of course, with design, we have geometry, PMI. You saw in the AVIs from production releases of all the tools that Daniel showed you how that would work today. The thread goes through and is traceable, which is an upside positive. On the quality side of things, which we tend to think of in Siemens here in Team Center Quality and Op Center and Easy Plan, you can add characteristics, you could add criticality and other items, but those things are not, let's say, known in the NX database. So today the flow works correctly, exactly as shown in the AVIs, but for most of our customers that are doing what you're trying to do, there's extra middleware and extra tracking, which means the robustness of engineering change or traceability is a challenge. To solve that challenge, what we're doing, as introduced earlier, is putting the characteristics per the DMSC compliant method up here in NX Design. Again, if you add characteristics in NX Design, that now is traceable in a closed loop engineering change across the same, because we have the master of that data, in one place, single source of truth. That can go out from NX through QIF to any of the other tools you're using. Could go out through QIF to other complementary tools or other competitive tools to Siemens NX. What we'll do in the connection here, to generically pointing here with Team Center Quality, is now the owner of the characteristics could be the NX, and Team Center Quality could be, as Daniel used the term, derived. So they could operate here, or the owner could be in Team Center Quality, and the NX characteristics and the NX part file could be derived. And again, that would be handled by permissions within our Team Center product. So within the Siemens suite, we would have a robust engineering change, inclusive of not only geometry, PMI, but now characteristics, which is new. What I think is more interesting today for the QIF audience is within NX Design, we have a layer here of an API called NX Open. The NX Open API will support the creation, extraction of QIF characteristics. So with Capvidia working off of NX Open, the characteristics could go to and from NX Design, so you would not have to have Team Center. You could go out to any of the other products that are in the row here, and the responsibility for tracking the traceability would be outside of and not require Team Center. So 2 deployment paths with NX and with all the Siemens products. In each of these boxes, we're open, and we have open APIs, so you don't have to be in our tool suite. If you have NX and Capvidia, NX and some of the other products, again, that are shown in the booth, that all holds together because the characteristics are stored associatively in one data structure with the PMI and with the geometry. Harder questions. So we're excited about what we're doing, and kind of for the conclusion of what Daniel and I have tried to share with you today as far as how the workflow would work in a real digital thread using the QIF things that you've talked about and UUIDs today. Let Daniel talk to you about the summary, and then we'll try to take any more questions.
Yeah, so just I guess a couple concluding thoughts. So first of all, I mean, let's just establish that model-based characteristics, model characteristics, these are important enterprise business objects. I mean, I think that's clear. In fact, I mean, just thinking about the previous slide, this is something that I think this community thinks that model-based characteristics are important things, and it's nice. It is kind of a nice validating feeling to see that a large CAD PLM company seems to believe the same. It shows that probably we're not crazy. So, or at least they're as crazy as we are, maybe. The next point is
they just seen the truth.
They finally listened to you. They found the truth. So yeah, the next point is just the idea that that QIF can be a really good glue for how to piece together these CAD and PLM business objects with other areas of your enterprise, including your supply chain. 3, that this is not, we can finally get away from PowerPoint diagrams and just thinking about things in theory, because there are commercial software tools that do these things. So I think now is the time to, for everyone to start getting their hands dirty and really start getting into some of these workflows and seeing what you can do. And I think, a final conclusion, just sort of on the general idea of model-based enterprise, and QIF itself. Usually the first thing that we think about when we think about the value proposition is the idea that you don't have to re-enter your work. It'll make your work faster, no data re-entry. And so you could do an ROI study where you can measure time the manual way and measure time the PMI-based way. And that's great. That's a great way to establish a nice ROI. But actually, at the end of the day, that's not the biggest value. I mean, the biggest thing is providing access to your data in a digital way at a more granular level and across your entire enterprise in an organized way. And that's what some of this technology is providing. And that really is, I think, the real value proposition of the model-based enterprise. And with that, any questions? Patrick. Oh, yeah, Bill.
Bill L. Leonardo here. Yes, just one question. So it's very interesting seeing how you're doing this extra enhancement. It looks like this was just for mechanical CAD. Does it also expand into the electrical and software domains?
That's a great question. We didn't talk about it in this session, but with NX, we have this similar sort of digital thread on both an electrical and electronic side. So the logical diagrams being in Capital or Expedition or in the IDX file. So when you say electrical, I'm not sure if you're talking about PCB boards and electronics or electrical, but the geometry today has a robust digital thread in our suite of tools. The PMI is in NX, so if the board information or the capital harness information or your harness information comes from another tool into NX, the answer to your question would be yes. The basis here is the same. Where the answer becomes no, there was discussion this morning about 2D drawings and kind of interpreting notes off of the 2D drawings. That is not part of this year's plan for NX. So we're not looking to kind of take the 2D information. We're really hinging the characteristics today off of the DMSC data structure, but hinging them into our system in NX off the PMI. So the limit will be less on electrical or on a type, and in my opinion, more on a 3D PMI. The answer would be yes. If those are on your drawing or in text forms, then the answer is not in this year. And anytime the answer is no, that just prompts opportunity to talk to me before I leave today. So if you have some valid workflows, the enhancements that we're talking about here, we have a product manager on my team working in a well-documented as-is and to-be workflow with customers representing how this works so that it's not just what we on the MCAD side think of things. And maybe the answer to question one from some of the PMI experts on my team is if I could pronounce the word meteorology better, then we would have done this a year or two ago. So we feel like we've been a leader in PMI. We have rules-based PMI and other things, and really building and leveraging off the strengths in NX in the PMI space and getting tucked into the other things that could benefit all of you is really what's our version of the answer to number one, but I accept the other two answers. So hopefully that answers your question.
Quick question. Do you guys have anybody doing this at like a product level right now? Because my main question is, you're moving this information into the product data, right? And there are a level of control that we exercise over product data, right? In terms of configuration management, it takes time, takes a number of hours, whereas before this sort of information is outside of that, could move much more rapidly. So like, how do you allow them to be able to make those changes while maintaining that level of configuration control? Because it does seem like it might cause some issues in configuration management. I don't know what they will do, but just, have you seen that yet? I guess.
I'm going to re-change your question into three questions, if you don't mind.
That's fair.
So I think the first question is anybody that's one of our customers or our mutual customers doing this today? Yes.
Okay.
Is it challenging to keep the traceability thread? Yes. Is that driving the enhancement that's coming in my part of the product? Yes. So that's kind of question one. The robust change, the traceability is a challenge, but I have customers, we have mutual customers today doing this. I think the second part of your question is really about throughput, right? So am I concerned that by putting some things in NX, that's going to make things heavier downstream? Right now, no. But that's one of the big things as we get closer to the release. We'll have a September pre-release event, and so scalability of the solution is something that we're watching and that we have specific targets for. We have ways that data in NX doesn't have to permeate everywhere in the system in other applications that may reuse it. So that's why I have some confidence that we'll have a performant solution, but that's always a concern.
Fair enough.
And I would say for part one, there's folks in the room, so they may want to search you out in the break, or you may have already talked to them.
I guess extension of your question, is this being used in the external, so the non-NX, the non-native environment? So we're Rolls-Royce, we use NX today.
Mm-hmm. Thank you.
8% of our supply chain doesn't. So if I embed my characteristics in my NX product, and I don't have Capvidia, where's my benefit coming? How do I get the supply chain to start consuming all that goodness, the effort, the energy I've put in?
Well, I could think of a solution.
Well, again, okay. Are you going to incentivize people? If how are we going to reduce it? Let's not go there. I guess it's where does this data go? Or if you can't answer that, technical data pack. Do I now have yet another format to put out there? Do I have to go and export a QIF?
Yeah.
Is it in a step? Think about external supply chain. I'm on board. I live in NX and Siemens. So how do I connect this down to the external supply chain?
Yeah. I mean, so I guess from my side, I think it is a very legitimate concern, the question of, okay, let's say that we have that QIF, it has the beautiful bill of characteristics that matches the bill of characteristics in NX and everything's great. Okay, but we put that in a TDP and send it down to our suppliers. Does that just answer the question? No, it doesn't. I mean, because are they sort of technologically enabled to be able to do anything with that other than be confused? And generally speaking, the answer is no. I mean, at first, it's going to be a heavy lift for them to know what to do with that QIF. And so, I mean, there are ways to sort of transmit that data to your supplier that's not in the format of a QIF file, but you would maintain the integrity of the bill of characteristics and maybe give them an easier view. So to give you an example, there's a third-party QMS, online QMS system that you're familiar with called NetInspect. So this is a system that we can take the bill of characteristics from NX and publish that bill of characteristics to NetInspect. The supplier can view that on NetInspect, do their work like they normally do, enter measurement results data up to NetInspect, and then we, on the Capvidia side, can pull that data back down from NetInspect. And so what happens is the integrity of that QIF data and of that bill of characteristics is maintained the entire time. And we have traceability back to that NX model. But from the supplier's side, the data that they're seeing sort of at rest is NetInspect data. That's, in fact, from their perspective, they might not even know that anything's changed. They're still seeing the same data interface that they're seeing. But on your side, you're tooling up to get ready for QIF. And in the meantime, while you're doing that, you start working with some of your key suppliers on showing them the benefits of, hey, here's a QIF file, and you have PCDMIS. Well, hey, we could show you what you could do with this QIF file and PCDMIS. And they start getting smarter. So that's typically what we've seen.
I guess I would add to that, again, kind of two parts. There's the sales medicine answer part. So what I'm trying to do in the NX product that I'm responsible for is drive differentiation so your suppliers would be interested in going there. And sales-wise, there's discounts for suppliers connected to large customers, which would be one part of the answer. Second part of the answer, you're obviously here at QIF Summit. There are a lot of other data formats out there. Some of my competitors talk about STEP as the main data format to move PMI back and forth. There's 3 international standards for PMI. There's hundreds for 2D drawings. Out of the 3 international standards, there's about 30 3D PMI entity data types. STEP today supports 7. STEP doesn't support characteristics. IGES doesn't support characteristics. The other MCAD systems don't have characteristics, so direct translators to and from NX and Pro E Creo, direct translators to and from NX and CATIA, NX and SolidWorks don't support characteristics. So there's a kind of a sales positioning answer, and then there's also the technical answer. Might STEP at some point in the future learn from me how to pronounce the word I still can't pronounce and then catch up in answer 1? Possibility there is yes. On NX, we're open on the data formats, so every single one of our data structures has an import-export NX open mechanism. So if STEP picks it up, we will update our STEP translator to do the same. Any of our partner, in addition to Capvidia, are tied in through NX Open. So any of our partner software products that tie into your workflow can work off the NX Open today and also satisfy the same. But you know, the starting point answer about is STEP going to make it work, you know, it doesn't support all the PMI types today. So, right, I think to me, there's a lot of file formats. You know, there's 20 or 30 that we support. The only one today that has this is QIF.
Thank you.
Mm-hmm. Curtis.
Speechless. George, Daniel, thank you. Applaud what you've done. I have 3 questions. Well, first one's just yes and no. When you pulled out QIF out of the NX with the characteristics, did you use NX Open? And then you got the characteristics. So the characteristics NX Open is updated for
So,
or did you use something else?
I'm going to answer that more than just a yes, though. Yes, the Capvidia interface to NX is using NX Open. The characteristics in NX today are not released. So what you see today in the production release doesn't have the characteristics, but the AVIs are current production release. So they're doing extra work to make that work. With our new release, because it's NX Open, I believe it'll be a reasonable lift for them to do the extra work to handle that.
So you did extra work today, but tomorrow?
Yeah.
Okay. Also, I think what I heard you say that not only did you put this in NX, the characteristics, but you also, whenever you uploaded it to Team Center, all those characteristics got separate objects inside Team Center as well, and there's a connection between
Correct.
NX and Team Center.
And I didn't really talk about that, but that's absolutely a requirement on our side.
Okay.
So Team Center will be enhanced to handle the characteristics object types, and the PML XML from Siemens, that is the interface mechanism with Team Center, equivalent to NX Open, will also be enhanced, and that will follow a little bit after the NX release timeline. So the answer to that is yes.
Do you see now that you got characteristics in your PLM system, Team Center, new opportunities that you could exploit?
Yes. And we're looking for reference customers to help us take that exploitation to other new reference customers.
And then my last question is, now that you, from Capvidia and NetInspect, you get all this part instance data, right? For serial number, you got all this kind of data. And if you load that back into Team Center, is that an opportunity to put part instance information, like quality evidence in Team Center to a part instance of, you know, like serial number 33?
I understand the question. I'm going to say I don't know yet what the answer to that will be. So we're in discussions as to what that may mean. Do customers want that to come from some other source as another item in Team Center, tracked with the same CAD master or something separate? Or would the path more reasonably be from another system into NX and then through the Team Center piece? So
I don't know, I just think that there's an advantage to have
So we-
part instance evidence,
yeah,
quality evidence inside.
we think we've laid an open foundation, which we're constantly striving for, but I don't think we've really answered that question yet.
And then-
So it's that which would tell you it's not in the short-term enhancement
Sure, that's
road.
fine. And so you mentioned NX Open. Is there a Team Center Open?
Yes.
Equipment? And then they would have this new characteristic.
Yes,
capability?
absolutely.
Okay, thank you.
Yep.
Very good.
Mhm. So I would say thanks to Daniel for adding Siemens and NX to the session a little bit at the last minute from some of the work that we've been doing behind the scenes. Gave us an opportunity to talk to some things that are new and also got me educated more about what all you do and what QIF means and how that'll work in our product. So thanks, Daniel, and thanks to all of you.
Yeah, thank you.